We have next example. We're supposed to write ones in the following cells. We have 0, 1, 7, 6. We are going to have two groups. This is group 1 and this is group 2. This group is placed in one row. Remember, anytime we have one row, don't think too long, just copy down everything, whatever is at the side of this particular row. So I have C0. This group is placed in two columns. The common variable for these two columns is B0, is the same for these two columns. That's why I'm going to write over here B0. Next group is placed in one row and two columns again. So I have to copy down everything, whatever is at the side of this column. This is nothing else, just C. And this group is placed in two columns. And the common variable for these two columns is B. Remember, we ignored the complements. As you can see, this is nothing else, just the exclusive NOR. Supposed to make this bigger. Exclusive NOR. I have C, exclusive NOR B. Okay, this is the simplest form of my function, because this function will contain 1, 2, 3, 4, 5 gates. This one is going to need just one gate. If you want to implement it, you're supposed to just draw exclusive NOR gate with input C and B. These are the solutions to my problem. Let's take a look at this example. I want you to be very sensitive anytime you are going to read the problem, which is going to involve the Karnaugh map. This time I have the sum of the product with the variables A, B, C. It means that my K-map is going to have variables A, B, and C. This is the order in which you're supposed to put the variables in your K-map. If you are going to miss that, your answers are going to be wrong. That's why, let me set this map in the new way. So I have A. A is going to control the side of the map. I'm going to write A and A. Anytime we have 0, remember, put not above the variable. And I'm going to have BC, 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 and BC. Anytime I have 0, just put not above it. This is the map which is prepared to solve this problem. I have ones in following cells: 1, 2, 4, and 7. Someone is going to say, uh-oh, how are we supposed to solve this problem? We can create the groups of 1, 2, 4, or 8 ones, but at this moment, all of them are put in the way that we cannot group them, because we cannot group the ones diagonally. So in this case, the K-map, we can say, is useless. We cannot use K-map to solve this problem. So how are we supposed to approach this kind of example? So what I'm going to do, I'm going to find from the Karnaugh map the SOP, sum of the products, first. And I'm going to use Boolean algebra to solve this problem. So I'm going to have A naught, B naught, C. Okay, this is the A naught, B naught. See, this is the term which is going to represent this high in this box. Or A naught, B, C naught, A naught, B, C naught, or I have A, B naught, C naught, and I have A, B, C. B, C. Let's take a look what we can factorize from these terms. I have C and C in these two terms, and I have C naught and C naught in these two terms. I'm going to have C, and inside of the parentheses I'm going to have A naught, B naught, or A, B, or factorize these C naughts, and inside of the parentheses I'm going to have A naught B or A, B naught equals C. This is nothing else, just exclusive NOR. I'm going to write A exclusive NOR B, or C naught exclusive, this is exclusive OR, A exclusive OR B. Because these are the complements, I'm going to call this one Q naught, and this one I'm going to call Q. And I have C, Q naught, or C naught, Q. As you can see, this is nothing else, just exclusive OR. That's why I'm going to write this as exclusive OR. C exclusive OR Q. But this is not my answer yet. We said that Q is equal A exclusive OR B. So I'm going to write C exclusive OR A exclusive OR B. Let's implement this, and I'm going to have, this is my C, and I have A exclusive OR with B, and C is exclusive OR with this exclusive. This is my output. So these are the solutions to my problem.